Hello, my name is Pablo Pino, and I will present our work about inspecting state-of-the-art performance and NLP metrics in image-based medical report generation. The task that we're studying is the medical report generation from images. Many deep learning models have been proposed in the recent years. These are able to receive a medical image, such as a chest X-ray, and generate a written report, as the one being shown. Most papers evaluate their methods with natural language metrics. These metrics measure n-gram similarity between two texts. However, some authors have noticed that these metrics may not be able to capture medical facts. Consider this example. There is a ground truth and a generated report with 3 sentences each. 2 of the 3 generated sentences are stating opposite medical facts from the ground truth. However, this sample achieves high scores in these natural language metrics. Hence, we can think that these metrics are not suitable for this task, as we should be measuring correctness from a medical point of view. So, in this work, we inspect these metrics and the performance by benchmarking some simple baselines and deep learning models. We implemented 5 simple baselines. First, a model that outputs always the same constant report. Second, a model that returns a random report from the training set. Third, a model that searches the most similar image in the training set and returns its report. And the last 2 methods use the most common sentences and words to generate a random report. Also, we trained a deep learning model that uses a CNN and an LSTM with an attention mechanism that generates the report word by word. We used the Indiana University dataset, which is the most commonly used in the literature. We evaluated using some common NLP metrics, and we used the Shakespeare labeler as an attempt to measure clinical accuracy. This is a rule-based method that classifies 14 diseases in each report. Then you can use classification metrics to measure how correct is a report from a medical point of view. Here are the results. The last 2 columns show the Shakespeare metrics, and in the rows you have the state-of-the-art, the simple baselines, and the deep learning models that we trained. In each column, the top 3 results are in bold. So, there are many things that we can see in this table. I will highlight the main 2 points. First, we can see that the constant model achieves near state-of-the-art performance in most of the NLP metrics, and it even surpasses some deep learning models, the ones from the literature and the ones that we trained. This is not expected, as any model that we train should be able to surpass this very simple baseline. Second, we can see that the models do not seem to be performing very well in a clinical sense, as the AUC score is near 0.5, which is almost as good as random. Though you can also see that most papers do not report this type of metric, as they only report NLP metrics. So, to sum up, we think that either state-of-the-art models do not perform very well in a clinical sense, or maybe NLP metrics are not able to differentiate between these methods. So, as future work, we think that further research is needed to inspect the performance of the models, and we think that many research questions should be answered, like, do NLP metrics correlate with expert judgment? And how to measure medical correctness? Are Shakespeare metrics enough to do this? Here are the references of our work. Thank you.